Hello everyone, back to the Handmade Hero Mac platform layer report. My name's Ted, and here to kind of continue things on. We're actually doing really well. I know it's been a little bit since I updated and made some more videos for you. Sorry about that. Just, it's snowboarding season, and I don't know. I got a lot of other projects, so. But we're working our way through this thing. And the last one, we actually managed to separate out the games, the game library into its own kind of separate dynamic library that actually gets loaded at runtime, which is pretty darn cool. We haven't actually seen sort of the full brunt or the full effect of what that allows us to do, and today we'll actually be able to see that, which is pretty freaking cool. What it lets us do, it lets us actually edit the game's source code while the game is running, and then there are certain things that we'll actually be able to watch what gets rendered to the screen change kind of in real time, which is pretty cool. So we're really not that far from being able to do that. So we'll just kind of dive right in. If I go to my main function. Not there. Let's see. So we've got this kind of idea. Oh yeah. So right here even we've got this idea of loading the game code. We created this kind of separate struct that represents the different. Actually represents the different function pointers that we're going to have, and those come from this dynamic library. So basically, all this does is it opens up the dynamic library at wherever it happens to be inside of the applications bundle. So we have to, on the Mac platform, usually whenever we open things, we have to have that be inside of the applications bundle. It's kind of like a sandbox environment. And so you move the files into the applications bundle, and then we can call DL open, which will just open it as a dynamic library. And then it's basically saying, hey, if there's, a pointer, if there's actually, something there, then we're going to set these function pointers for update and render. Update and render just, we pass it a pointer to a display buffer bitmap, and then our game library fills that bitmap up with some pretty things to display to the screen, gives us a frame basically, and then we display that frame later. Similarly with samples, we just give it an empty sound buffer, and it gives us some chunk of time that kind of represents just like a 30th of a second, or like a frame's worth of audio is basically what this gives us. So if we're able to get those function pointers set, then we say it's valid, and we can then we can actually load the game code. And we're using this Mac load game code thing right here. So pass it a pointer to this thing called this game code structure, and where we believe the game library is. The only thing that we're going to do now that's different is we're going to make it so that in this while loop somewhere, if that library has updated, if it's been written to, then what we're going to do is we're just going to reload the library. So it's actually pretty simple if you think about it. So there's a few kind of we'll get into it, but all we need to do is, so we go back, we go here, we've got this Mac game code. Now we're just going to add this new concept of kind of like the last time that the DLL, the dynamic library got written to. So we're tracking that, right? So let's call it DLL last write time. And then what we're going to do is, so now I have this concept of last write time, but we need a function to actually go and get that for us. So I think we'll just put that right here, and I think it's something get last write time. And all we're going to do is just pass that character pointer to the name of the file that where we want to know when it was last written to. And actually, this is all this is like kind of a platform specific thing. It's this other library, so it's not super interesting kind of what that code is, because that's actually a thing that we're not really doing ourselves. So I'm actually just going to kind of grab some stuff. I think it's like this. Yeah, so we need this. We need sysstat. So that's definitely one that we need. And then that's actually what gives us this like stat object, or this stat structure that then yeah. So I'll just walk you through this. It's a pretty simple thing. So actually, this is going to be a pretty short video. So let's see. Yeah. All right. So we've got just the result of what we're going to return here. Just so by default, that's nothing. And then there's a stat that's like, that's part of this stat library. And we just initialize one of those empty. We call upon this stat function. Actually, let's look at sysstat.h and see kind of what that's all about. I'm sure it'll maybe give us a little more detail about what that's doing. Sysstat.h. Okay. Defines a structure returned by, okay, and stat, so stat function. Stat takes character pointer to the path, and then a stat buffer. Any time-related fields. So yeah, that's what we're passing it. So we're let's go back. Not state. Yeah, so we pass it the file name, and then we pass it the pointer to this stat structure, right? And I believe that function must return 0 if it was successful. We can probably get a little bit more into that. This is like from the Unix specification. So we'll fail if, okay, so there's a bunch of different fail things, but this may not be the best. Upon successful completion, 0 is returned, otherwise -1 is returned, and error number is set to indicate the error. Okay, so it's another one of these kind of error returning functions in C. And yeah, the buff argument is a pointer to a stat structure as defined in the header sysstat.h, which we were looking at. So let's see, stat. The structure contains at least the following. Okay, that's good. Let's see. What do we? Yeah, we use st_m time. Okay, so just kind of st_m time is the time of last data modification. So basically, we're looking at like when was the last time this this file, which is the game library DLL, when's the last time that got written to? Well, if the thing's running and then we recompile the game, it's going to be written to at a different time. So then we can kind of do a little comparison there. I'm guessing a time t is just like an unsigned 64-bit integer, because usually time is represented that way, but that's kind of what I'm thinking. So if this thing returns successfully, great. Then what we're going to do is we're going to say, we're going to use this, the DLL last write time is going to be this m time of last modification. Return it. So we want to do a few things. First thing we want to do is anytime we try to load the game code, we should really be calling this get last write time. And the reason is because, well, we want we want to have like we need like kind of a basis of comparison. So we need to like, if we load it first and then we set the original time when it was loaded to some time, then that's actually we can then use that to later compare when it got written. So every time through the game's loop, every time it's gonna update, render a new frame, and then display the frame, every time through we'll actually just check to see if that DLL got modified, and then what we'll do is we'll load it again if it did get modified. So we're gonna go game DLL last write time equals get last write time, and then we're going to pass in this game library full path. And we just do this at the beginning. It kind of, doesn't really matter. So that's going to happen. And now, kind of what we need to do, now that we've got this get last write time function, we've got the game to where it's definitely when it loads. So we got Mac load game code right here. It loads once at the very beginning, right before we kind of hop into this infinite while loop. It loads once, and what we want to do is probably right before we ask the game library for a frame, what we should do is just check to see if that DLL has changed, and then if it has changed, we'll just reload it. So that's kind of what I'm thinking. So let's see, game dot update and render. Here it is. So this would be like right before we pass the buffer to the memory, and the display buffer, the memory, etc. So now what we need to do is we need to figure out new game library write time. Let's just call it that. And again, all it is Mac get last write time, and then we want the game library's full path. Okay, and it's just pretty simple. If game dot DLL last write time is less than new game library write time, then we want to basically reload it. So that would make a lot of sense. So we'll say Mac load game code. Okay. I just want to game code. Okay. So we're going to pass that in. Now, it's also kind of nice, well, not just kind of nice, I think it's actually something that we have to do. So we need to unload the game code before we actually load the game code again. So that's going to be pretty important, because we want to clean up after ourselves. So we just need to make sure now that we're going to be reloading the game code, we want to kind of clean up. So we'll just do this. Mac unload game code. Pass it a pointer to this Mac game code thing. Game. I don't think that there's anything else that we need to do there when we do unloading the game code. We don't need to pass in anything. So basically, all we're going to do now is we're going to kind of close up all this other stuff, all the other properties, and we should also do this. So all these pointers. Function pointers, update and render. We're just going to close those out, and then think we also want to do this DL close game code DLL. I know I had done, I usually do these before, so let's kind of see where we landed. Yeah, okay. Yeah, close, okay, I guess DL close will will close if we, yeah, that makes a lot of sense. Okay, I'll just use this, it's fine. Probably don't want to close it if it's not valid. So there's that. All right, and so that's all this is doing is it's just if we've got, you know, a pointer to our dynamic library, right? Then let's just close out the library and set the pointer to 0 so we're not thinking that we are, you know, able to load some stuff into it. And then we want to make sure that we are not pointing to the same functions anymore, so just kind of clean that up. So we got Mac load game code and then Mac unload game code, and we're just going to pass in pointer to the game code. All right. Now let's see if we can build. Okay. Oh, just okay. I guess just function naming. Get last right. Let's call it Mac get last right time. No big deal. It's actually fewer compilers than I saw earlier, so that's good. What? Oh, that's right. Okay. Okay. Consistent naming here. Okay, so Mac get last right time. Got it. All right. Okay, so it builds. Fantastic. All right. Now we've got some cool stuff we can do here. So what I'm going to do is I'm going to go in and we're going to, so we got this thing running. So you see this. This is going to seem kind of magical. So now this is the platform layer, okay? So I'm just closing out the platform layer because if you modify the platform layer while it's running, you're going to actually have to close the app or close the game. But if you modify the game library, you don't have to close the game when you reload the thing. So here's kind of the magic. So let's say I've got my renderbird gradient, right? And right now what we've done is we've said, if you can hear me over this, God, this is loud. So right now what we're saying is there's no red, right? And if I look at this window, it's pretty darn clear there's no red, right? But if I change this value so that every time we draw the red pixel, we're drawing the maximum number of red, without closing the game, we suddenly have red. Pretty darn cool. Really cool. So this is live code editing, actually. So as you are using this thing, you can kind of keep it running, and then you just go in, step in here, and modify your game library. You know, maybe that was too much red, so we say, okay, that's 128. Fine. That changes. There's all kinds of things you can do if you want to. I mean, you know, I don't know. Maybe we just do. What was I was doing some like. I think it was something like, you know, you can do stuff like this too, like Let's see how this works. I think you can like just make it go kind of more in one direction or something. Oh, oops. Well. Okay, well I'm gonna get I don't know. I'm just having fun now because it's pretty cool. Okay, yeah. So like funny things like this, like what did I actually do? Well, I changed it. I changed the renderer so that anytime it steps in the Y, it's gonna go like 4 times as fast, which means that since I'm drawing the green as like this unsigned 8-bit integer, if I'm multiplying it by 4 every time I increment it, then it's going to fly through the possible values for an unsigned 8-bit integer way faster. So it's gonna go all the way up to 256. 0 to 255, and then it's gonna overflow. It's gonna do that a lot faster now that I've like multiplied it by 4. So I could maybe even do something like y divided by 4, just to like, and then what that'll do is it'll just make it so that the same thing is like way longer. Does this? Yeah. And you can still see that those lines are there. It's just that it takes longer to go all the way through all of the possible values in an unsigned 8-bit integer. So, those are the kinds of things that you can do. Pretty cool. There's a few things that you can't do. So, well, there are a few things that are going to, how shall I put this? So, if I'm looking at this memory here. That's super annoying. Okay, can you still hear me? Maybe you can. Hello? Okay. I had to turn that volume off. I guess I could just modify the game library as well and have it so that it just doesn't output any sound. So what I'm doing here now, this memory, it has a default value, right? Now, anything in here that I try and modify in the game library, if I rebuild it while it's running, is probably not going to work. It's definitely not going to, because this memory was already initialized, right? So what's going on is, the reason this works, the reason we can even do this, is because, let's go back to that, platform layer right here. The reason that this works, that we can just straight up reload the reload the game code while it's actually running, is because of this, because the way we do memory. So remember, we made a decision here earlier on that we wanted to, and I'm gonna close this now, so because we don't really need to see it. We made a decision that we wanted to allocate all of the memory for the game up front, right? So this is what's going on here, and we wanted to know what its base address was as well, at least if we're building kind of in a development mode. And the reason that that's helpful is because if we tell the system to allocate the memory at the same base address every time the app is built, then when we rebuild the app or the game, it's expecting the memory or the state for the game to be in the same place. And that means that all we need to do whenever we draw a frame is we just pass a pointer to that memory over to the game library. At least in a development mode, that location of that memory never changes. It's actually consistent. Even if we rebuild the whole project, it's consistent, which leads to some other very cool things. So since that state, the game state, is actually preserved in between building. So what do I mean by this? What do I mean by saying the game state is actually preserved? Well, let's say I run this now, okay? Here's our game, And some of the things that we define as game state, we define a few things as game state. Offset X, offset Y, tone hertz, right? So these are a few things. If I move so I'm pressing on my PlayStation controller, if I move this thing just a little bit to the right, say, and that's my offset X, right? And maybe I'll just change my offset Y a little bit as well. So now I've got a little bit of a different offset Y and a little bit of a different offset X than the default value here, which is 0 and 0. So you see that? Now, if I go in and I change, let's say I want like no red anymore, just as an example, and then I reload, the game library, what do you notice? Well, what I notice is that the offset X and the offset Y never changed. It didn't reset the game, right? That's because rebuilding the project itself actually doesn't change where any of that memory is. And so what's going on here, and we're not we're not reallocating it or anything like that. So the state actually gets preserved even when we swap out the game library live as we're actually running the game. So the offset X and the offset Y and the tone hertz, those are the things that we kind of defined as the game state. That's in our permanent storage over here, right? In that block of memory that we pass over to the game to have it render a frame. That's actually preserved. So what does this mean? Well, it means some really, really cool things that are coming up. And I know this is a bit of a short video, but kind of what's next is because all of this state is preserved, one of the things that we can actually do that's special to this particular kind of like architecture, as it were, we can have the game record a series of inputs and the actual state of the game, the memory, for a certain period of time. And then what we can do is we can actually have it play that back over and over and over again. And that would be really, really useful for something like, tweaking a character or, the position of watching, let's say we draw a player on the screen or something like that. If we then are able to record sort of what happens while somebody is playing a game, we can play it back. So maybe one thing I'll do just kind of quickly before wrapping, I'll show you what I've been able to do using Casey's platform layer. I actually have a platforming game, like a 2D platforming game that I built based off of it. And so I'll just show you some of the stuff that I can do kind of in a debug mode. Now this is like, I've made a little bit of progress here, but so I've got this guy running around. This is actually, it's fully moved over to metal rendering, which is pretty cool. It's a lot faster now. Renders at 60 frames, which is great. Feels great to play. But check this out. Because of this memory architecture, because of this dynamic loading, I'm going to press the L key on my keyboard. And I'm moving around, I'm playing it, this is great, whatever, right? Okay, now I'm going to press the L key again. And you see how it's just going over my same actions, it's just recording it? Well, it's pretty cool because we've got the state of that memory, we can actually just write the memory to a file. And then what we can do is we can actually record the inputs from the controller as somebody is playing, and we can write that to a file. And what we can do is then just swap out the memory, and then pass that memory pointer to the game library at a different time. And so here's kind of a cool thing: is watch as this is playing. So we got this guy kind of jumping around, right? Well, let's say now I need to navigate to my actual game here. Yeah, so I'm gonna navigate to my game, and I'm gonna modify something, right? So what I'm gonna do is I'm gonna go in, I'm gonna my platformer game. I guess I got my game library. This is, I took a ton from Handmade Hero. So anyway, not everything. I had to like kind of invent some of my own stuff, which is pretty cool. But let's say, okay, so like let's look at the jump code. So this is the part of the thing where I tell it like how much we want the guy to jump. So see how my replay is kind of going. We're replaying, starting over. So my guy can jump so much. He jumps like 30 units, right? Well, what if I change that to 40 units, right? And then I just build it. Okay, what happens? Okay, making the shader library, making the platform layer. Okay, great. We're done, right? And now, do you notice maybe you don't notice the difference. I'm not sure if you notice the difference. He's kind of jumping a little higher, isn't he? So if I wanted to kind of like tweak some of these things, some of the, what is it like, what's the jump like? Maybe I'll just like make it a super crazy number or something like, I don't know, like 140, just to like really hammer the point home. As it's compiling, right? So now, there you go. So and you see like everything else in the game works. It's like it's the same input, right? It's the same stuff that's coming from the controller. It's the same button presses, the same left on the right on the D-pad, and X from the PlayStation controller. It's just that like the amount that we're jumping is just like totally ludicrous, right? All because we have this architecture where we allocate the memory for the game's state up front, and we then we keep the game library as kind of a separate thing. It takes a pointer to a display buffer, and it also takes a pointer to the start of that memory, which means that we can just swap that memory out whenever we want to. We can load a file. We can do a bunch of different stuff. So now I can return it back to like a little bit of sanity here. I can say, okay, 30, and then there we go. So we'll rebuild it, and lo and behold, we're back, back to back to just seeing how it was. I've also got it set up so if I press the L key, now what that did is it stopped taking input from a file that we loaded, and it's taking input from the controller. So I'm moving around, playing, etc. This I just wanted to kind of show you. So you think it's cool that we can like swap out the what gets shown on the screen, like say what gets drawn, what gets rendered. But it gets even cooler because we can actually do this like live recording of what we're doing as we're playing. This becomes really, really valuable kind of at later stages of development of a game, where let's say let's say I get all the way to the boss, at the end of the game, and I'm like fighting him or whatever, and I want to tweak that. Well, do you really think it's going to be fun to have to like, go and get to the boss, close the game, go all the way to the boss, get to the boss, fight the boss, and like while you're fighting the guy, then you make a change in the code, and then you have to like reload the, close the game and like do it all over again. This is cool because I can just like save my fight with him. I can press the L key, save my fight. Oh, here I'm doing my thing. Okay, then like, all right, let's watch as that fight goes through. And what did I like? What did I not like? Let's kind of go back over that again. Oh, this is a little bit different. That's not what I thought it was going to be. Oh, maybe it is. Huh. Anyway, it's pretty cool. So, that I actually, I don't really have time right now to go through all of doing the different replay buffers. So setting it up so that it's loading So you can do something like this where the only difference is we would be taking the memory for the game state, and we'd be saving it to a file, and then we'd also be saving all of the inputs that come from the controller. So that's kind of up next. Now that you've actually got it so that it's dynamically loading the game's code, we're going to start doing some kind of fun things with memory that then allow you to for developing a game in particular. This is really useful. Actually, in my job doing iPhone app development, I wish I had something like this, because it would just be really cool. I mean, there are things like I guess like React Native lets you do it, but it's not in the same way. It's this like it's got to go over this like JavaScript bridge, and you still don't like have like real compile time safety or anything like that. And so it is a kind of like live edit thing, but it's not nearly as cool as this. I actually would like to try and build something like this, but for iPhone application development, something where it's like there's dynamic libraries that can get swapped in and out kind of as you're using the application. It would be pretty darn useful, because there are a lot of like little design tweaks and things. And I think one of the pains about mobile application development for a lot of people is they want a way to be able to modify the user interface kind of like while they're running the thing, sort of similar to this. And think, we're doing this all without having to do a scripting language or anything like that. So we get all of the benefits of having an actual frickin' compiler, and we get the benefit of being able to modify the source code for the game while it's running. Like cake, eating it too. In France, they say, you can't have the butter and the money for the butter. I think this is like having the butter and the money for the butter. And if you really want to like dig it in France, you would say like, you can't have the smile from the Dairy Maiden. And I think with this, we just got the smile from the Dairy Maiden. So with that said, thank you very much for watching. Let me know if you have any questions. There's a lot that's going on. I actually think at some point I am going to cover metal rendering, because it was such a useful thing in my game. It was like the difference between getting from 30 frames to 60 frames. So I think I'm going to extend the series a little bit further than kind of what I had intended, and the purpose is sort of changing a little bit, just a little bit. But right now, actually, where you are, you should be able to pretty closely follow Casey's series, at least at the very beginning. So I feel like we've gotten very close to accomplishing the original mission. So I will see you next time.